Welcome back to the class on electrical vehicles and hybrid electrical vehicles. Initially, we are going to see the control of three-phase voltage source inverter. First, let me define the inverter. Inverter is a powertrain circuit which converts the fixed DC voltage to the variable AC voltage. There are two types of inverters are there. One is single phase inverter, second one is a three-phase inverter. But in this class, we are seeing only the three-phase inverters. Voltage source inverter. Whenever the input voltage to the inverter is independent of the load, then it is nothing but a voltage source inverter. There are different control techniques are available for the voltage source by means of which we can control the RMS output voltage of inverter as well as the frequency of the AC voltage. It is broadly divided into the two types. Pulse width modulation technique, another one is the phase vector modulation technique. In pulse width modulation technique, different control techniques are there, but we are focusing only on the sinusoidal pulse width modulation. Three-phase inverter is consisting of 6 switches S1 to S6. S1, S3, S5 are the S1, S3, S5 are the odd group of switches. S2, S4, S6 are the even group of switches. Across each switch, we place a one diode. This diode is nothing but a feedback diode. The diodes are come to the picture only when load is consisting of inductance. Suppose from the odd group of switches, let me take S1 is on. Once the S1 is on, this terminal A phase will be directly connected to the positive terminal of the input voltage. The A phase voltage becomes a plus VD. Even group of switches, let me take S4 is conducting, then the same A phase will be subjected to the minus VD voltage. So another name for these switches are nothing but a positive group of switches. Another name for the S2, S4, S6 are the even group of. Here we kept a one capacitor which will maintain the constant DC voltage to the inverter, because we are assuming that we have taken this inverter as a voltage source. On the same lag, two switches should not be on because it will be making a directly short circuit across the voltage. So the switches may be the burn source. Three-phase inverter is nothing but it is a powertrain circuit which converts the DC voltage to the three-phase AC voltage. Whenever we are saying the three-phase AC voltage, it is consisting of three phases: A phase, B phase, C phase. Each phase should be displaced by 120 degrees and the frequency also should be the same. So, how do we get this three-phase voltage means? In case of a sinusoidal pulse width modulation technique, we have taken the reference voltage as well as the carrier voltage. The reference voltage is nothing but a sinusoidal signal. Carrier voltage is nothing but a triangular signal. Here the triangular signal is nothing but a bidirectional triangular signal. So both we are comparing. In the comparator, we have written the logic such that when the reference voltage is greater than the carrier voltage, then the output becomes 1. So this is directly given to the S1. The inverted signal will be given to the S4. The same manner VR2. VR2 is nothing but it is also sinusoidal signal. This sinusoidal signal will be lags VR1 by minus 120 degrees. Again the same carrier signal will be compared to the reference signal. Same logic we have written. If the output is 1, the signal will be directly given to S3. The inverted signal we are giving to the S6. This is the third sinusoidal signal which will be lags VR1 by minus 240 degrees. The comparator again we have written the same logic. This signal we are giving to the S5. The inverted signal we are giving to the same thing we are going to see in the waveform. We have taken the vertical axis as well as the horizontal axis 0, 60, 120, 180, 240, 300, 360. This is the reference voltage 1. This is the reference voltage 2. This is the reference voltage 3. Now this reference voltages we are comparing with a bidirectional triangular signal. The bidirectional triangular signal we are comparing with the A phase, them to VR1. Then we are getting this. These are the pulses for the S1. The opposite pulses we have given to the S4. The same manner, when the same triangular signal we are comparing the B phase, then we are getting the signals for the S3 and opposite signal we are giving to the S6. Similarly, VR3 we are comparing with a triangular signal. We are getting the signal for the S5 and opposite signal we are given to the S2. In this manner, we are generating the base voltages to the switches so that the switches will be on whenever the base voltage is 1. The base voltage 0, the switches will be off. Now, how we are going to control the output voltage means by means of a modulation index. Modulation index is defined as the M equal to magnitude of reference voltage by carrier voltage, VR by Vc. The modulation index always lies between the 0 to the 1. VR is nothing but a magnitude of a reference voltage, nothing but maximum value. Vc is nothing but a or VR. VR is nothing but a maximum value of carrier signal. This carrier signal. By changing this magnitude, we can control the RMS output voltage. Suppose if we want to control the frequency of the output voltage, then we have to change the frequency of a reference voltage so that output frequency voltage will be controlled. In this manner, we can control both magnitude as well as the frequency of a AC voltage by changing the modulation index as well as the frequency of a reference signal. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel so that I am always welcome to answer all your questions.